The first thing you must note, these are the equation we're going to be using. We have this one, D equals to U plus AT. Okay, and then you must know that your V is the final velocity. Okay, V is the final velocity and is measured in meter per seconds. It's measured in meter per seconds. So we can write it this way or this way. Okay, the U is the initial velocity. Okay, then we have A as the acceleration. A is acceleration. A is acceleration. It's measured in meter per second square. Okay, which you can also write in this form. T is your time. T is measured in seconds. Okay, T is time measured in seconds. Okay, then another one is the displacement, which is the average velocity times time. Okay, your displacement is measured in meter. Another one again is v squared equal to u squared plus 2ax. These are the equations we will be using. These are the equations we will be using. Okay, these are the equations we'll be using. Another one again is this one, x equal to ut plus half at squared. So these are the tools to be using. Okay, these are the tools to be using. As you're coming in, just begin to say I. As you are coming in, just begin to say I. And you must know, okay, if you look at the equation 1, we have 4 parameters. So if you want to use it, you must know 3 of the parameters. 3 of the parameters must be given, then you find the 4th parameters. A straight horizontal road traveling at 8 meters per second. It passes a pillar box, and 6 seconds later it passes a sign. The distance between the pillar, between the pillar box, the distance between the pillar box and the sign is 60 meters. Find the acceleration of the car. Find the acceleration of the car. The first thing that I said in the first part is to write your parameters. Okay, you have U is traveling at 8 meters per second. Okay, the car is traveling at 8 meters per second. That's U. Okay, T is 6 seconds. T is 6 seconds. Okay, and then we have the distance as 60 meter. As 60 meter. Okay, so you can see the units conform to each other: meter per seconds, seconds, meter. So we are going to look at the equation to use. We're going to look at the appropriate equation to use. We can see this one. Can we try this one? Ut plus half at squared. Can we try this? We have U, we have T, and we have the distance, and we are looking for the acceleration. Acceleration, we don't know. Acceleration, we don't know. I think this is the best. This is what we're going to use. Okay. So this will be equal to what? The distance is 60. The distance is 60. U is 8 times 6 plus half. My A, I don't know the values of A, but my time is 6 seconds. Okay, and that will give me 60 equal to 48. 8 times 6, that's 48, plus 6 squared, that's 36 over 2. 48 equal to 18a. So that will be 12. 60 minus 48, that's 12 equal to 18a. And then you can make your A as the subject. A is equal to what? A is equal to 12 over 18. Okay, 2 goes there, 6 goes there, 2, 6 goes there, that's a 3. So that's the value meter per second square. Meter per second square. Okay, meter per second square. So if you are just coming in, okay, you are in the right place. Just begin to say I as you are coming in. If you are fresh on this channel, please subscribe so I can keep track of the update of this channel. Okay, begin to give the videos a thumbs up. Okay, and share the links of this video across your different platforms. We have a cyclist traveling at 12 meters per second, applies a brake, applies a brakes, and come to rest after traveling 36 meters in a straight line. Assuming that the brakes cause the cyclist to decelerate uniformly, find the deceleration. So let's write the parameters. It's traveling at 12. So U is at 12. My U is at 12. Okay. When the body, okay, when the object come to rest, okay, so the final velocity is equal to 0. When the object come to rest, the final velocity is equal to 0. Okay. Traveling at 36 meter. Distance is this 36 meter. Okay, and then assuming that the brakes causes the cyclist to decelerate uniformly. When there's a deceleration, that means our acceleration value will be negative. Okay, deceleration means negative acceleration. Okay, so let's say acceleration we don't know. We are looking for that. So let's see the formula that connects that connects U, V, and the distance. We can use this one. You can try this. Let's check. Is it going to work? My V is what? I know my V, I know my U, I know the distance, but I don't know the A. So this will be 0 square plus my U is what? 36 square, and then plus 2 times A. My A, I don't know, but I know the distance as 36. Okay, that's 36. Okay, then you can move this one to the other side. That will be 36 square. That's minus that, equal to 72A. So A is equal to 36 square over minus 36 square over 72. That's that. Minus 144 equal to what? 72A. Make your A the subject. That's minus 144 over 72. And that's what? That's equal to what? Minus 2. Okay. Unit is very important. Okay. So acceleration is what? Meter per second squared. A particle moves along a straight line from P to Q with constant acceleration 1.5 meter per second square. The particle takes 4 seconds to pass from P to Q, and PQ is equal to 22 meters. Find the speed of the particle at Q. Find the speed of the particle at Q. So Q is the last point. Okay, so that means V is unknown. Okay, we have the acceleration as 1.5 meter per second square. We have the time as 4 seconds. Okay, we have the distance as 22 meter. The distance is 22 meter. Question 4. Your answer will be for question 4. It's going to be minus 8 seconds or 2.5 seconds. So yeah, we are going to knock out the negative because time cannot be negative. Yeah, if you look at the question, we have a train is moving. A train is moving along a straight horizontal track. Horizontal track with constant acceleration. The train passes a signal at 54 kilometers per hour. 54 kilometers per hour. And the second signal at 72 kilometers per hour. The distance between the two signals is 500 meters. Find in meter per second the acceleration of the train. The acceleration of the train. So what we're going to do, we've been told that we should make our acceleration in meter per second square. But the speeds are in kilometer per hour. So there will be need for us to convert the speed from kilometer per hour to meter per second. And how do we do that? How do we do that? The train passes a signal, okay, at 54 kilometers per hour. So that will be U, and that's what? 54 kilometers per hour. So convert this to meter per second. That will be 54 kilometer. Kilo is 1 kilometer is equal to 1,000 meters. So that will be times 1,000. Okay, and don't forget 60 minutes. 60 minutes is equal to 1 hour. 60 minutes is equal to 1 hour. Okay, and let me start from here. 1 minute is 60 seconds. A minute is 60 seconds. 60 minutes, okay, we make 1 hour. 60 minutes will make 1 hour. Okay, and then we can convert this minute to seconds, because a minute is 60 seconds, and that will be 60 times 60 seconds, making 1 hour, and that's 3,600 seconds is equal to 1 hour. Okay, that means kilometer per hour, that will be over 3,600 seconds per seconds. Let's get the V, the final one, a second signal. V is 72 kilometers per hour. Okay, per hour. Okay, convert this to meter per seconds. 1 kilometer is 1,000 meters. Per mean over, and hour is 3,600 seconds. Okay, if you do this one also, 0 we cancel, 36 here 1, 36 here 2, so giving us 20 meter per seconds. 20 meter per seconds. And then the distance between the two signals, we have the distance as 500 meter. Okay, find the acceleration. Acceleration we don't know. So let's see the equation that connects all these parameters. Let's see the equation that connects all these parameters. Square equal to u squared plus 2ax. Let's try that. We know the v, we know the u, we know the distance, but we don't know the acceleration. Okay, so this is it. If you try this one, this will not be applicable because we don't have the time. We don't have time. Okay, we don't have time. Okay, we don't have time. So this is very this is applicable. So v is what? V is 20 square. U is 15 square. Okay, plus 2 times acceleration. Our distance is 500. Okay, so we have 400 minus 225. 15 square. I think it's 225 equal to move this one to this side, and this will be 1,000 A. This will be 175 equal to 1,000 A. So make A the subject. That's 175 over 1000, and that's 0.175 meter per second square. So that's that on that question. Okay, if you're new, please subscribe to the channel, say hi as you're coming in, share the links on your different platform. Okay, thank you. Thank you. So let's see what we have here. We have a particle. A particle moves along a straight line with acceleration from point A to a point B. Okay, where AB is 48. At A, at A, at A, at A, the particle has speed 4 meters per second at A, so that will be U. U is 4 meters per second at A, and at B, it has a speed of 16 meters per second. So that will be the final velocity, which is 16. Okay. And then we have the distance as 48 meter. We have the distance at 48 meter. We have the distance at 48 meter. We have the distance at 48 meter. Okay. We're trying to find the acceleration. Acceleration we don't know. So let's find that. Okay. So at A, we have U. At B, we have the final velocity. Okay. So that's what we have there. As you're coming in, just begin to say hi. Share the links of this video across your different platforms. Begin to share the links of this video across your different platform. This is good. You can apply this. My V is 16. My U is what? 4 square plus 2 times A. The distance is what? 48. Okay. So it's going to be, move this one to the side, to the other side. That's 16 square minus 4 square, okay, equal to 96A. 2 times 48, that's 96A. Okay, so make A the subject. Make A the subject. Make A the subject, and then you get your answer for the acceleration. Punch your calculator. Acceleration will be 2.5. 2.5 meter per second square. 2.5 meter per second square. So we can make a statement that the acceleration, okay, of the particle, the acceleration of the particle, acceleration is 2.5 meter per second square. So that's that. Then the time now, the time it takes from A to B, the time it takes from A to B. Let's see the equation we can use. Let's try this one. Let's try this. Already we've got an acceleration. We have the distance. The distance from A to B is 48. Distance from A to B is 48. My U is 4. My time, I don't have time. Okay, and that's what I'm looking for. Okay, plus half times 2.5 times t squared. So that will be 48 equal to 40 plus 2.5 over 2, that's 1.25. Okay, 1.25 t squared. 1.25 t squared. Okay, so that's what we have there. 1.25 t squared. Or we can multiply the equation by 2 to avoid this 1.25. We can multiply the equation by 2, and that will be 96 equal to times 2, 80 plus 2.5 t squared. And that's equal to what? 2.5 t squared plus 96 equal to 0. And then we can use try this equation. We can try this equation. V equal to U plus AT. My V is 16. My U is 4. My A is what? My A is 2.5 T. So this is more easy, and that'll be 12 equal to 2.5 T over 5. 24 over 5, and that will give us 4.8. I think 4.8 for the time. That's a 4.8. Question 7. The driver of a car. The driver of a car is traveling along a straight road. Along a straight road. When she sees an obstruction ahead, she applies her brakes, and the brakes cause the car to slow down, to rest with a constant deceleration of 3 meters per second square. Find A, the distance traveled as the car decelerates. B, the time it takes for the car to decelerate from 18 meters per second to rest. U is equal to 18 meters per second. That's our U. Okay, it's traveling at 18 meters per second along a straight road. Okay, she applied her brakes, and the brake caused the car to slow down to rest. Okay, when the car slows down to rest, V will be equal to 0. The final velocity will be 0. Slow down to rest. Let me come to rest. Okay, so V is 0. Acceleration, we have a constant deceleration. That minus 3. Okay, meter per second square. When there is a deceleration, it means acceleration is a negative value. Acceleration is a negative value for deceleration. Find the distance that travel as the car decelerates. So the distance, let's see what we can use here. We can use this one. Okay, my V is 0. My U is 18 square plus 2 times acceleration, that's minus 3, times the distance, that's what we are looking for. And that will be equal to 2 times 3, that's minus 6. Take it to the other side, that's 6x. 6x. And that will be what? That will be 18 square, which is 18 times 18. Okay? So distance will be equal to what? 18 times 18 over 6. Okay? So that will be 6 here 1, 6 here 3. That's 18 times 3. 18 times 3. That's 54. Okay? Massively give like to this video, subscribe. Okay? The second one, the time it takes for the car to decelerate. Okay? The car decelerates from 18, U equals to 18 meters per second to rest. V is 0. So does not change the time it takes for the car to decelerate. And our acceleration, we've already gotten deceleration at minus 3 meters per second square. Because in that, then we can get the time. Okay, the time. I think we can use this equation. We can use V equal to U plus AT. We have the V as 0. We have the U as 18. We have the A as minus 3 times T. Okay, then you can move minus T to the other side. So that's 3T equal to 18. And T is equal to what? 18 over 3. That's 6 seconds. So that's the time it takes for the car to decelerate from 18 to what? To 0. Okay, that's the time it takes for the car to decelerate. Okay, a particle is moving along a straight line OA with constant acceleration 2.5 meter per second squared. At t equal to 0, the particle passes through O with speed 8 meter per second and is moving in the direction of OA. It's moving in the direction of OA. The distance OA is, find the distance travel, find the distance taken for the particle to move from O to A. B, the speed of the particle at A. Give your answer to 1 decimal place. Give your answer to 1 decimal place. Let's begin to give the parameters. I've said first thing to do is to write your parameters. You're going to state the parameters. After that, look for the appropriate equations to use. We have acceleration 2.5 meter per second square. That's acceleration. At O, the particle passes through O, okay, with speed 8 meter per second. Okay, so U is what? U is 8 meter per second. Don't forget, it's from O to A. So it passes from O. So that will be the starting point, and that's U. Okay, and then we have the distance OA, distance from point O to A. The distance is 40 meter. It's 40 meter. Let's get the time taking. So the equation that connect this, we're looking for the time taking. T. I think we can use this equation. X equal to ut plus half at squared. You can use that. Okay, my distance is 40. Okay, my u is 8 times t, you don't know t, and then plus half times a, my a is 2.5, and then t squared. So that's what we have in this case. We can remove that half by multiplying multiply the equation by 2. So this will be times 2, that's 80, times 2, that's 16t. This place also times 2, that's a plus what? 2.5 t squared. Okay, this as form quadratic equation. So we now have 2.5 t squared plus 16 t minus 80 equal to what? Equal to 0. Then you can use quadratic equation. A is 2.5. Okay. B is 16 plus 16. C is minus 8. Is equal to minus b plus or minus square root of what? B squared minus 4ac. And that will be equal to my b is what? That will be minus 16 plus or minus b squared, that's 16 squared, minus 4a. My a is 2.5. My c is minus 80. Okay, all over what? All over 2 times what? 2 times a, 2 times 2.5. Okay, so that's our time. That'll be 2.999 seconds. Okay, and we are told to make it 1 decimal place, so approximately 3.3 seconds. Okay, so that's that on that question. So let's quickly see the B part. The speed of the particle at A. The speed of the particle at A. The speed of the particle at A. So we can try this equation: b squared u squared plus 2ax. Okay, the speed of the particle at A. So that's a v. My u is what? My u is 8 squared. 8 squared plus 2 times a is 3.229, or let's say 3.3. Okay, let's use the raw value 2.99, and then times the distance is what? Is 40. The distance is 40. Okay, let's do it this way. So this is equal to what? B square U square plus 2AS. Mistakes here. Our A is 2.5. I'm using time. Our A is 2.5, 2.5, and then times 40. 2.5 times 40. That's my A, 2.5. So here also change it to 2.5. 2.5 times 40. 2.5 times 40. Okay, 2.5 times 40. So that will be equal to square root of what? Square root of 64 plus 2 times 2.5, that's 5, times 5 times 40, that's 200. That's 200. That's square root of what? 264. Deceleration, that's A is equal to minus 5. That's the deceleration. At t equal to 0, the particle passes through the origin O with velocity 12. We've already said it's origin O. So that's U equal to 12. U equal to 12. Our U is 12 meters per second. Okay. In the positive direction, at time t seconds, the particle passes to the point A with S coordinates 8. S coordinates, that's the horizontal. So the distance is what? Is 8. 8. That should be 8 meter. I'll check the question. That's 8. S coordinates 8 meter. 8 with S coordinate 8. Find the values of t. Find the values of t. That's the A. So these are given parameters. These are the parameters we can decode from the given information. This is the parameter we can decode from the given information. Okay. Then the next thing to do now is to look for the appropriate equation, kinematic equation or equations of motion to solve these questions. Okay. Okay. As they're coming in, just begin to say I, share, like, subscribe. Share, like, subscribe. Say I as they're coming in. Call someone now to join us. Okay. Call someone to join us. Call someone to join us. So the equation that will be applicable, we can use this one, x equal to ut plus half at squared. Okay. We have the x as 8. We have the u as 12. 12t, don't know t, plus this become minus half. The acceleration is minus 5 times t squared, and that will be equal to 8 12t minus 2.5 t squared. Okay, so we can move these 2.5 to the other side. 2.5 t squared. Okay, move this one to the other side too. Minus 12t plus 8 equal to 0. So if we like, we can multiply the equation by 2 so as to cancel these decimal, and that will be 5t squared minus 24t plus 16 equal to what? Equal to 0. Okay. Okay. So that's what we have. We can factorize this. 16 times 5, that's 80. Factors of 80, that can give us 25. That can give us 24. Okay. That's 16, 80. Let's check that. 240, 220. Okay. 16 and 5. 8 and 10. 8 and 10. Yeah. 8 and 10. 20 and 4. We're going to use 20 and 4. 20 and 4 is the best. 20 and 4. And that will be minus 20 minus 4. So t here. Okay. This is if you multiply this one with this one, that's a plus 80 squared. And the two factors of 80 that can generate minus 24, that's a minus 20t minus 4t. So we just come back to this equation and replace the middle one with these two factors. Okay. Please subscribe right now. Subscribe. By just coming in, subscribe right now so I can keep track of the update of this channel. So we're going to have 5t squared, okay, minus 20t minus 4t, okay, plus 16 equal to 0. Begin to pair the first two and the last two. 5t is common. Okay, we have t minus 4. Here also minus 4 is common. That will be t minus 4 also equal to 0. So t minus 4 times 5t minus 4 equal to 0. So t is equal to what? T is equal to 4 or 4 over 5. So seconds. 4 seconds. 4 over 5 seconds. T is equal to 4 seconds or 0.8 seconds. So that's it. That's that for that. Okay. That's that. Find the value of t. We've done that. We've gotten the value of t. We've gotten the value of t. Then we'll go to the b part. The value of t is gotten. Okay. The values of t is gotten. The values of t is gotten. Begin to share the links of this video across your different platform. Begin to share the links of this video across your different platforms. Share. Begin to share right now. Share the links. Subscribe. Okay, like. Give the videos a thumbs up. Give the videos a thumbs up. Give the videos a thumbs up. Share. Like. Subscribe. Okay. Give the videos a thumbs up. Okay. So that means you appreciate the effort. Subscribe so as to keep track of the update of this channel. Subscribe so as to keep track of the update of this channel. I. Okay. From which country are you, sir? I've said it many times. Okay, I'm from Africa. And precisely, I'm from Nigeria. Okay, I'm from Africa. I've said it many times. Okay, and teaching has been my hobby. I've been teaching for the past 20 years now. Okay, I've done that in the Middle East for 10 years. Okay, so the experience is there. So when we are talking, we know what we are saying. Okay, I'm not boasting. To God be all the glory. Okay, to God be all the glory. I've been teaching more than 20 years. Okay, I've done it outside my country for some years. Okay, we make money to the glory of God, and we continue to make more money in Jesus' name. Okay, so let's see this question. Let's see this question. Let's see this question. The B parts. The B parts. I don't want to clean this one. The B parts. What do we do now? Okay, what I would do, I'm going to leave the B part for. Okay, let's finish it. Let's finish it. Questions still continue. I'm going to give a quiz. I'm going to give like 2 questions for quiz. Okay, and then you submit those questions. Those are solutions on the comment section. I'm going to give like 2 questions for quiz. Just drop it. Drop the answer on the comment section. Okay, let's see the B part. We want to find the velocity of the particle as it passes through the points with the s coordinate equal to what? -8. Okay, the s coordinate equal to what? -8. So we have x equal to -8. Okay, and I think the other parameters remain constants. So we can try this one, v squared u squared plus 2ax. Okay, we're looking for the velocity. We have the initial velocity as 12 squared plus 2 times our a is what? Our a is minus 5. The distance is minus 8. The distance is minus 8. That's the quiz for us. Okay, that's the quiz. That's the quiz. That's the quiz. Okay. What we're going to do for the quiz, let's look at the questions together. Okay. We have a car is traveling along a straight horizontal road with constant acceleration. The car passes over 3 consecutive points, A, B, and C, where AB is 100 meter and BC is 300 meter. The speed of the car at B is 14 meter per second, and the speed of the car at C is 20 meter per second. Find A, the acceleration of the car, B, the time taken for the car to travel from A to C. So that's the question, that's the quiz for us. Okay, this is mechanics 1 M1 for AX and A level. Okay, the class continue. So I don't know, I'm not sure today when I'm coming today, I don't know. Okay, so our updates. Okay, please subscribe so that you can keep track of the update of this channel. You can know when I will be online. Okay, you can know when I drop a new video. Okay, subscribe right now. You're yet to do that. Please do that now. Call your friend, call everyone, your classmates. Let everyone do the same thing. Okay, subscribe right now, subscribe right now. This is the best moment. Subscribe right now. Okay, at this point, I want to appreciate every one of us for staying by, for subscribing, for sharing, for the likes. And if you are yet to do all those ways I mentioned, subscribe, like, share, please do that right now. Thank you once again. See you my next video. Bye bye.